Here we will be solving rational inequalities using a graphing approach. If you would like to see the more traditional, where you use test points, please refer to the other video. A graphical approach, almost the same as the traditional approach. We need to make one side of the inequality 0, and that's so we can compare above or below 0, positive or negative. We want to combine all the terms into a single fraction on the other side. We've got to find when the numerator and denominator equal to 0, so those are our boundary points. Then we're going to put these points on a number line, and then we're going to look at a corresponding graph to help us decide either above for greater than or below for less than. Right? So this first example, we have 0 on one side and we have a fraction on the other. Okay, so the first two steps are done. I'm going to set the numerator equal to 0, the denominator equal to 0, and I'm going to solve. And I'm going to place these on our number line. Now, as I do that, I want you to think about, we have -3 and +2. Where does this come from? This comes from the denominator, and remember, in a function, that would be our vertical asymptote. In a function, this would be our x-intercept. That's where the graph is going to cross the x-axis. And I'm going to put an open circle because it says greater than. Then I'm going to look at my graphing utility, which I have right here, and I'm going to say, all right, here's my x-axis. Here's this part above, which is over here, because this should be at x equals to 2. That's my vertical asymptote. And then the second part looks like it goes by the asymptote, it comes up, and it comes through -3 right at about here, and then it goes above the x-axis. Now, because our problem says greater than, what I want to do is I want to shade everywhere there's above the x-axis. And then I want to write my answer in interval notation. So what part of the graph is above? All of this and all of this. How does that correspond to the x-axis? From -infinity to -3, that's this part. And then from 2 to infinity, which would be this part. Put a union symbol, and there's your answer. On this example, notice there's not a 0. So the first thing we need to do is subtract 1 from both sides so we can have that 0. The next step says we have to rewrite this as a single fraction. So I have to find a common denominator, which is x minus 4. So that means I need to multiply this fraction by x minus 4 over x minus 4. So I have -1 times x minus 4, and that's less than or equal to 0. Notice I'm taking the time to put parentheses here to help me remember to distribute that -1. I'm going to now collect like terms. 2x minus x is x. 3 plus 4 is 7. Right. I'm going to set the numerator and denominator equal to 0. I'm going to get x equals to -7 and x equals to +4. Putting those on the number line in the correct order. Again, remembering this comes from the denominator, so that's my vertical asymptote. Right? And because this part is equal to, and that's my x-intercept, that's going to be a filled-in circle. Then I come up here and look at my graph, and sure enough, this looks like a vertical asymptote. So we have this part of the graph that's up here. Then the second part comes down close to the vertical asymptote, gets to -7, crosses at -7, and then goes above. We're not looking at how pretty the graph is, just whether or not that above and below part. Okay, and since that's less than, I want the part that's below the x-axis, so I want this part right here. Then I want to write my answer in interval notation. The -7 is included, so that's bracket, and then it gets really, really close to +4, but it doesn't cross it because it's that vertical asymptote. Right? Again, we don't have 0, so we've got to do some algebra. So I'm going to subtract 1/2. That's greater than 0. This time the common denominator is both of those, so that's 2 times x minus 1. So I need to multiply this fraction by 2 over 2 and this fraction by x minus 1. So I have 2 times x plus 2 minus 1 times x minus 1, again being very careful about that minus, is greater than 0. So let's distribute. Collect like terms, 2x minus x, 4 plus 1. All right. Setting the numerator equal to 0, setting the denominator equal to 0, and solving. Okay, divide by 2, that cancels. So then I add 1. Okay, and again we're going to put those on our number line in the right order. Let's see, this came, that's from the denominator, so that's a vertical asymptote. This is the x-intercept, but since it's greater than, it's just going to be an open circle. And look at that graph, looks almost exactly the same as the other ones. Here, comes up and goes above. And what part do we want? We want above the x-axis, so that's this part and this part up here. Alright, so I want this part of the graph, this part of the graph. That goes from negative infinity to negative 5, parenthesis this time. Remember, this was at 1, so from 1 to infinity. This one a little bit harder, algebra. Going to subtract. Going to have that very important 0. Finding a common denominator, which would be both of these. Alright, so I need to multiply this one by x plus 3. This one by x minus 5. And I like to show all my steps so I won't lose that minus. Then I need to distribute. Collecting like terms, 2x minus x is x, 6 plus 5 is 11. Okay, so setting the numerator equal to 0 and solving for x, setting the denominator. And this time we have two factors, so we set each factor equal to 0 and solve, so I get x equals to 5 and x equals to negative 3. Again, that's from the denominator, so those are asymptotes. And again, look at this graph, and you can kind of know that your algebra is correct if it matches the picture I'm giving you. All right, so let's look. We're going to put all those on the number line. Negative 11 is way over here, then negative 3, then positive 5. All right, those are our vertical asymptotes. This is going to be our x-intercept, and since it's equal to, it's going to be filled in. Now we look at the graph. Looks like it's up here. This is below the x-axis, and this part is above it, but we know it gets down to a negative 11, even though we might not see it on the picture, and we know it crosses and it goes below. Now, what part do we want? We want less than, so we want below the x-axis. So yes, definitely this part is below the x-axis. But once it crosses that negative 11, since it started above it, it's going to come below. So we want all of this part and all of that part. All right, so we've got from negative infinity to negative 11 bracket because it was filled in, union, parentheses because those are vertical asymptotes that can never be touched. So once again, this is a graphical approach where we're using screenshots from the graphing calculator to help us answer those questions.